Welcome back to 10 minutes lectures in computer science. In this lecture, we are going to discuss about two-phase locking protocol. DBMS typically uses log-based protocols to safeguard database from inconsistencies. The log-based protocol is a set of rules to ensure that the effect of both concurrent and serial execution of certain transactions should be identical. To ensure this property, log-based approaches uses two types of logs. One is shared log, the other one is exclusive log. Shared log is used to log data items for read-only operations. For example, if you want to check your balance in your account, or if you want to check for the availability of tickets, or if you are checking your attendance percentage. So these are all some of the read-only operations where you need to log the data items using shared log, that is log_s. On the other hand, exclusive log is used to lock the data items for update operations. For example, you want to withdraw the money from your account, or you transfer money from your account to another account, or if you want to book the ticket. In these cases, we need to lock the data items in exclusive mode so that we can change the values. We can update the values. How does log-based approaches work? It works based on the log compatibilities. Let us look at this log matrix where two transactions are represented. In this case, both transactions trying to lock data item A, and they can be permitted to lock A simultaneously only if both have requested for shared lock. In all the other cases, they are not permitted to lock the data item. For instance, assume that transaction 1 has got the exclusive lock on A. In that case, transaction T2 cannot either take a shared lock or an exclusive lock on A. Instead, it has to wait until transaction T1 releases the lock on A. For example, look at the schedule where T1 starts first and consumes a lock on A, exclusive lock on A. Now T2 is also requesting for an exclusive lock on A, but these two locks are incompatible. Hence T2 has to wait until T1 to release the lock. Two-phase locking protocol is a log-based approach. It consists of two phases. Under 2PL, every transaction is divided into two phases. One is growing phase, the other one is shrinking phase. In growing phase, a transaction may obtain locks, but it is not allowed to release locks. In shrinking phase, transaction may release locks which are already acquired, but they are not permitted to obtain any new locks. Let us see an example of this. Here, this transaction transfers money from account A to account B. So we need data items A and B should be locked in exclusive mode. Instructions 1 and 6 does that thing. Once you have successfully executed instruction 6, that means you have acquired all the locks. At this point, you have reached lock point. It is a point at which the final lock is acquired. At this point, we are considered to have completed the growing phase and enter into shrinking phase. So during shrinking phase, we can execute some of the operations that are part of a given transaction, and we are permitted to perform unlock operations. No new lock request can be generated during this phase. We have three different versions of two-phase locking. The basic one is simple two-phase locking, where we release both shared and exclusive locks during the shrinking phase immediately after consuming the locked data item. Let us discuss about simple 2PL with an example. Here we have a transaction T1, which is a read-only transaction. At the starting of the transaction, we are in a growing phase where we request for new locks as per the 2PL protocol. Here we need shared locks on data items A and B. So as per the lock request, the lock may be granted by the lock manager. Then we locked A. Likewise, lock is B will request for lock on B. If both the locks are granted, then we are said to be in the lock point. We have reached the lock point. So after this lock point, we are going to execute the remaining instructions that are part of the transaction and releasing the locks one by one. Like this, unlock A, releasing A, then we are unlocking B, released B. Here, the instructions of this transaction may be executed in this particular order. It is not necessary, it's not compulsory to lock all the data items before start executing any instructions. It is not true. Once you have locked A, the next instruction is reading A so that you can read A. But the thing is you cannot unlock A because unlock A can be executed only after lock point during the shrinking phase. But other instructions can be executed. Here we have executed instruction 1 and 2 during locking of A. After locking of A, then we are executing 4 for locking B. Then during the shrinking phase, we are executing instructions 3, 5 and finally 6. What is the problem with simple 2PL? It may lead to cascading rollback. Let us discuss this with an example. In this schedule, transaction T1 locks data item A in write mode and changes its value. Then it needs lock on B, then it continues with B as well. Once we acquired the lock on B, we are going to release the locks on A because we have already consumed the data with A, that is at the lock point. We are going to release the lock on A and that will be immediately consumed by T2, which is waiting for exclusive lock on A. Now you see this schedule, T2 only works with A, but T1 works with A as well as B. For some reasons, if T1 wants to roll back, then it rolls back the value of A as well, A to the new value. But what happened? T2 has consumed the value which is written by T1, hence T2 also need to be rolled back. And it continues to all the transactions which have consumed the value of A after T1 started. So this is the cascading rollback problem. How do we get rid of this cascading rollback problem? Is using strict two-phase locking, where we retain all exclusive locks until end of the transaction, that is commits or aborts. We just retain all the locks, all the exclusive locks until we commit or abort. Let us discuss that with an example. So strict 2PL for exclusive and shared lock, you see here a transaction T3 reads A, locks A in write mode, locks B in read mode. Then growing phase, as usual, we acquire locks on A, then we acquire lock on B. Now we reach the lock point, then we can start releasing the data item. But as per strict 2PL, we cannot release the exclusive lock, that is the lock on A cannot be released, but in this shrinking phase, lock B can be released. Then we are releasing lock A at the end of the transaction, that is during commit or abort. In another case, if both are exclusive locks, in transaction T2, just recall, we try to lock both A and B in write mode. Then as usual in the growing phase, we lock A and we lock B both in exclusive mode. Then we reach the lock point. Now we start consuming the data. Once the data are consumed, in shrinking phase, we are going to release all the locks at the end of the transaction. We release A and B at the end of the transactions. And the instructions are executed in this manner. So instructions 1, 2, 3, we lock A, read A, write A. is executed first, then 5 to 6, that is lock B, read B, write B is executed first. Then at last the instructions 4 and 8 are executed after everything is completed. This is strict. Let us discuss the drawback of strict 2PL with the schedule S1, which has two transactions T1 and T2. T1 reads A and modifies A, whereas T2 modifies A. T1 is the first to execute, hence it locks A. As per strict 2PL, only exclusive lock to be retained until commit or abort. Hence, once B is locked successfully, T1 is going to release A, and immediately A will be locked and changed by T2. Now, if for some reason T1 rolls back and restarts, it will never see the old value of A that it has read already. This may be a drawback for certain transactions. To overcome that problem, we have rigorous two-phase locking, which is more stricter than strict 2PL. In rigorous two-phase locking, we are going to retain both the shared and exclusive locks until the end of the transaction. That is, we are going to retain them until we commit or abort. Let us discuss rigorous 2PL with an example transaction T3, where it involves both exclusive lock and shared lock. So as usual, during the growing phase, we are requesting for locks. First one is A on exclusive mode, we locked it. Then we request B on shared mode, and that too is locked. Now we have reached the lock point. Now as part of shrinking phase, we are going to retain both exclusive lock as well as shared lock. That is, we are going to retain the locks on A and B. Once we have reached end of the transaction, that is during commit, we are going to unlock both A and B. This is done with rigorous 2PL. There are few problems with 2PL. They are deadlock, starvation, and cascading rollback. Deadlock is a case when transaction on cyclic wait for some data items locked by other transactions in the cycle. Starvation is a situation where a transaction is keep on waiting for an exclusive lock on a data item which is being used by several other transactions in read mode. And cascading rollback already we have discussed, but a strict 2PL can avoid cascading rollback. In this lecture we discussed about lock-based protocols and the locks. Also we have discussed about two-phase locking protocols and their benefits in concurrency control mechanism in database management system. Thank you.